So before we start talking about an antiderivative, it's basically exactly what it sounds like. You know, what do you do to undo an antiderivative to go back to the derivative? And I'm going to take you back for just a second to like an inverse function. What do you do to start off with y equals x plus 1 divided by 5 to get to the inverse function? So if we say that this is f of x, so we've added 1 and divided by 5. So let's talk about what's going to happen when we get to the inverse. So you know to get the inverse you switch. So x equals y plus 1 divided by 5. So switch the x and y. Then solve for y. So 5x equals y plus 1. Y equals 5x minus 1. And that is the inverse function. And you might be thinking, what the heck does this have to do with calculus? Well, it's basically you're going to do the opposite operations in the reverse order. So up here with the original function, you've added 1 to x and then divided by 5. And when you look at the inverse, you know, the inverse operation of division by 5 is multiplication by 5, and the inverse operation of adding 1 is subtracting 1. But we've actually done those two inverse operations in the opposite order, because here you added 1 first, then divided by 5. Here we're multiplying by 5 and then subtracting 1. So now let's take this and talk about the antiderivative. So if you have something like f prime of x equals, I don't know, x squared plus x, and we want to figure out how to get back to the function, let's think about what we did to take a derivative. We multiply the exponent times the coefficient and then subtract 1. So you hear that multiplication and then subtracting 1. So the inverse operations are going to be division and adding 1, except we want to do it in the opposite order. So instead of multiplying and then subtracting, we're going to add and then divide. Sorry, I keep saying that wrong. So we're going to take the x squared, we're going to add 1 to the exponent, and then divide the coefficient by the new exponent. And then here again, we're going to add 1 to the existing exponent and then divide that new exponent and the coefficient. The cool thing about taking an antiderivative is that you can always check your work by taking the derivative. So is the derivative of 1/3 x cubed indeed x squared? And I think you can see it is. And the derivative of 1/2 x squared, is that derivative x? So let's talk about this again. If you have a function f prime of x equals ax to the n, then the function is x to the n plus 1, then you take the new exponent and you divide it into the existing coefficient. If you've already looked at this assignment, you're going to see that there's this wonderful thing called plus c, plus a constant. And I think if you think about it, if I added 5 to this, there, add 5, isn't the derivative of 5 0? If I'd added 55 to it. So you really don't know if there is a constant, and if there is, what it is. So we always say plus c. So let's go and look at another problem. Let's say f prime of x equals 7 times the square root of x plus, I don't know, 3 over x. So before you actually take the antiderivative, I want you to do the same thing that we did when we learned how to take a derivative and rewrite it. So that's 7x to the 1/2 plus 3x to the -1. You want to see that radical as a fractional exponent. You want to see that denominator as a negative exponent. And now let's go through the algorithm to take an antiderivative. We're going to add 1 to the 1/2 and get 3/2. and then we're going to take the existing coefficient 7 and divide it by 3/2. Next term, we're going to add, I kind of messed up here. And I am not going backwards. I'm just going to change this to 3 over x squared because there's an extra special trick to x to the -1, and we don't know that yet. Sorry. So we're going to change that to x to the -2. We're going to add 1 and get x to the -1, and then the existing exponent divided by the, the existing coefficient divided by the new exponent. And then we're going to tack on a plus c because you just never know if it's there or not. Cleaning this up, if we want to, we get 14/3 x to the 3/2 minus 3 x to the -1/2 plus c. Again, to check your work, you would take the derivative of this and see that your answer is 7 times the square root of x plus 3x to the -2. Okay, that's pretty much the nuts and bolts of going backwards, of taking a function that is the derivative of something and going back to the original function. We'll take the trig a little bit at a time. I hope that you have all memorized that the derivative of sine is cosine, and the derivative of cosine is negative sine. So when you're asked to take the antiderivative of, let's just say 5 cosine of x, then your function, and I just don't memorize all these antiderivatives of functions. I go, the derivative of what is positive cosine? Well, the derivative of sine is cosine, so this answer should be 5 sine of x plus c. So you hear what I'm saying? Instead of memorizing the integrals of the trig functions, I just kind of ask myself in reverse, the derivative of what will give me positive cosine. This works the same with sine. If f prime of x is -2 sine of x, then again, the derivative of what gives me negative sine? Well, the derivative of cosine is negative sine, so my answer is just 2 cosine of x plus c. And for tonight, that's really all the trig we need to worry about. There's a lot of what we call techniques of integration, undoing chain rule, product rule, quotient rule, but we have to start small like everything else and just talk about the basics of the antiderivative. The C is called the general solution, meaning that there could be an infinite number of solutions to this, and unless we have some specific information, we really don't know what C is. So I'll show you how to handle something like that. If they tell you that f prime of x equals 3x squared plus 2x, and that f of 1 equals 5, then this piece of information right here is called an initial condition. An initial condition enables you to actually solve for C. This is the one place where the function will, the graph actually goes through this point. So let's go backwards here and find f of x. So we're going to add 1 to the exponent and divide the new exponent by the coefficient. Likewise, we're going to add 1 and divide, and then just say plus c. So this is a pretty nice little function here. It's just x cubed plus x squared plus c. And then plugging in 1, f of 1 equals 1 cubed plus 1 squared plus c equals 5. So c equals 3. So with our initial condition, instead of leaving c in the answer, our particular or specific solution is x cubed plus x squared plus 3. And that may not get you all the way through the homework, but it's a darn good start. Thank you all for your patience and for your understanding while I have been a little bit out lately, and I will see you tomorrow.